Ooh, I think I've heard the word commercialization more times in the last 36 hours than in the previous 5 years combined in this community. And that's, in some sense, a welcome change for me, because I definitely have switched my own focus more to try to turn out tools, things people can actually use. It's a very different kind of activity than turning out papers. There are a lot of different things you have to keep in mind when you're trying to commercialize something, when you're trying to ship a part or anything else, than when you're trying to crank out a paper. I just have a couple of things that I jotted down to throw out as things we could talk about, and then we should either go with those or come up with something else. Don't really have an agenda. But within the U.S., genetically modified stuff now contributes about 1% of GDP, which is a pretty big number. Revenues are growing, depending on where you look within there, about 20% a year. Less than half of that contribution is from drugs. More than half of it is from unregulated things like fuels and materials, enzymes, whatnot. So synthetic biology at the moment doesn't contribute anything to that fairly substantial number. But given the talks we've heard already, it seems like pretty soon it will. As scientists, usually we're involved mostly in the R and R&D and not in the D. I think most, and this is certainly my experience, most of us don't have a good feeling for the fact that the D takes about 9 to 10 times as long, costs about 9 to 10 times as much, a general rule of thumb. And at the end of that D, you finally have something you can slap a label on and ask someone for their credit card number for that they may or may not want to buy. But it's a very different kind of thing than we're used to. And it certainly hasn't been discussed in the community here very much. And then actually getting something on the market, whether it's a protein, like I'm trying to get to market, or a fuel, requires a whole bunch of other things to work out for you besides the technology that you happen to have. There's IP, which we can talk a lot about, especially if we're going to try to talk about parts that are biobricks that are in the public domain. That's something that hasn't been worked out yet, as far as I understand, what the license might look like. Regulation, financing, customer demand. To navigate competition, you also have to worry about the feedstocks, if it's a high-volume thing, and the effects of the increase in demand on those feedstocks. So we have this collision between food and fuel that we've been seeing for about the past year. That's often misinterpreted in the way that biofuels are all bad and they're solely the cause of driving up the price of food, but in fact it's very complicated. It's certainly true that for ethanol you're drawing on things that look like food, and that's brought up the price of food. Biodiesel is often frowned on for the same reason, except it's demonstrably not true that the use of biodiesel has driven up the cost of vegetable oil. Why is that? Because vegetable oil costs more than diesel does. Right? Vegetable oil as food costs more than diesel does, which means that you will sell that vegetable oil into the food market before you'll sell it into the fuel market. What else do I want to say? That's about it, I guess. So I didn't want to spend a lot of time talking about my experience unless people had questions about that. I'm sure there are other entrepreneurs in the room. I can do that. Anybody have any other questions? Anything else they want to say?
Yeah, for those of us who haven't heard the story, your background, basically don't know who you are, can you do a little background?
Right. So I'm Rob Carlson. If you've heard the phrase Carlson curves, the plot that Drew showed this morning, the pace of change of technology, et cetera, that's me. The name, comes from publications. I didn't call it that. And I'm not sure that it's actually that important, other than noting that we've seen a lot of technological change as a result of Moore's Law. Biology is changing at least as fast. In particular, productivities in synthesizing and sequencing genes are increasing at least as fast as productivities due to CPUs. So we should be seeing some change in the economy from biology soon too. Why haven't we? Well, until very recently, it was too expensive to have access to most of those technologies. Now, anyone in this room can build stuff in their garage. So that's what I've been doing. I left academia a few years ago, got very frustrated, especially with the NIH, and then stepped out into the commercial world. Once again, I've actually jumped back and forth a couple of times. And now I'm getting ready to ship a tool for proteomics. Engineering tool, could be for diagnostics, wide variety of uses. So I come at this from thinking about measurement and thinking about how to get stuff working in the world. And that's driven me from, basically from academic positions into how do I get stuff in people's hands? How do I actually get products that people can use to change the world?
Are there biotech incubators where... What's the state of biotech incubators? I presume there are biotech incubators. It sounds like there are going to be quite a few people like yourself who could benefit from use of a lab, who could benefit from maybe someone else seeing the potential in the idea and then supporting the development of it. So do you know about that area?
So I should say that my other hat, aside from my startup, Biodesic, is with a consulting firm called Bioeconomic Research Associates, or BioEra. And in that capacity, I spend a lot of time looking at the bigger picture of the intersection of biology and the economy, including how innovation does or doesn't work often. We've looked at fuels and vaccines and SARS and the avian flu, and at incubators. And the problem with incubators, so yes, there are lots of incubators. Not clear to me that they're focused at the right kind of customer, where their customer is a startup. Usually, when you get an incubator, there are two kinds. One is a commercial venture. The other is something run by a state or university, something like that. The terms that the university operation will give are usually better than a commercial operation, but they're also usually oversubscribed from startups that come out of the university or some associated organization. The commercial incubators tend to want way too much. They tend to operate like VCs, basically. So they're going to provide you space in lieu of financing and expect you to give up a hunk of your company. As someone so that's why I went to my garage, actually, because I didn't want to deal first with that, and second, I couldn't afford it just for that space. It wasn't enough for me. And if you look at the larger studies of the way incubators or there's a word that is escaping my jet-lagged brain. Accelerators, something like that, sure, why not? The problem is that in my opinion, they're kind of focused a little bit too high in the food chain, and they're not contributing very much to local economic growth. So if you look at the way computers worked, a lot of the economic growth we have now from hardware and software is because people could do things in their garage. People could do things very cheaply. They didn't require a lot of overhead. That's what enables me now to work in my garage. I outsourced a lot. I outsourced gene synthesis. I outsourced protein expression. But the other stuff I did myself because I could. It was cheap enough. If incubators could offer more flexible, less expensive space, you'd have people trying that out. So we could, explore the safety dimension of that. Do we really want people doing stuff in their garage? I would argue, yes, you can't stop it, but you could make the argument, fine, we should make incubators available as a safety issue. Want to try the microphone here? Or? Okay.
Can you describe what your lab setup was in your garage, and what are the sort of tools that you think people are going to need in order to have do garage biotech?
Right. I chose my project very carefully so that I would need very little. It still, I don't think, is really easy to set up a gene synthesis shop in your garage. I can imagine how to do it, but especially after what I've seen here, I think I've seen now all the pieces necessary to build a desktop gene printer. I think it'd probably take about 2 months to put the hardware together, 6 weeks, something like that, if you had access to all the resources. I chose to just require basically the ability to run gels and do basic manipulations. So nothing more than you might do in a high school AP bio class, or probably less than AP bio class now, actually, the way things are going. And I was able to outsource the rest of it, molecular kinetics, measurements, the synthesis. Haven't found yet a good, cheap protein expression shop. If anybody knows of one, love to hear about that. But again, I chose my project very carefully. I knew that I wouldn't have to do very much myself. And I should also say that I was setting up that shop just about the time the FBI guys in biohazard suits were raiding Steve Kurtz's house. And I definitely didn't want that going on. We could talk about, what that really means too, how reasonable that was, whether this of course is just a U.S. concern primarily, but whether the FBI in particular has figured out what they need to keep us safe versus just harassing poor artists who don't really know what they're doing even.
In terms of if you were going to say that this is a garage startup, these are the tools that they're going to need, microscopy, chromatography, these kinds of things.
I don't need any of that.
You don't need any.
I don't need any of that. I can imagine needing it, sure. I mean, it depends on what you want to do. The question, of course, is what experiments do you think you're going to have to do to show that it works? All I needed was to run gels, do some other very simple stuff. If I wanted to get more complicated, yeah, I could make use of a microscope. But then again, I could probably make use of a $300 USB digital microscope from ThinkGeek or whatever, right? There is a lot of cheap technology out there. It's just that I set up my shop so that I wouldn't need it right away.
I guess maybe it's obvious based on how you just described your shop, but I was wondering, since the Steve Kurtz thing went down around the same time you were being set up, how you think the reaction would have been if that had happened to you? If there had been an air conditioner fire in your house, the police came down, whatever, saw it in your garage, would it have been the same or different?
Well, I intentionally didn't grow anything in my house for precisely this reason. So would it have been easier for me to get stuff done if I'd had to rely on cloning instead of synthesis that was outsourced? If I'd had to grow bugs to make protein? Maybe that would have been easier. I don't know. But in fact, I chose not to for this specific reason. If they'd shown up, what? I don't know. They would have seen.
They wouldn't have gotten excited.
I don't know if that's true or not. I mean, if you listen to Steve Kurtz explain his FBI interviews, it's pretty clear. Well, you could interpret it two ways. You could say they sent in a guy to interrogate him who knew a lot and played dumb. Or you could say they sent in a guy who was dumb. And I wasn't there. I don't know. You can make up your own mind.
But you probably have basic chemicals.
I do, yeah.
So they would come and see those, and they were probably dumb, and they would probably think, oh, terrorist.
Maybe. I tried to keep that. That's quite possible. I mean, fortunately, I didn't do that experiment.
I mean, I do a couple of things in my basement, but I worry about it.
Uh-huh.
I mean, you say you outsource this and outsource that. How did you get the money to do the outsourcing?
I was out of my pocket and consulting. So we bootstrapped the business off consulting and savings and whatnot. And now we're at the point where it's just too slow, actually. So anyone who wants to try this, I would say, great, give it a try. But in my experience, consulting jobs do show up. You never know exactly when. You never know how much work they're going to be. You never know how long they're going to last. And it's just too damn distracting. If you want to, our job ought to be making a screwdriver, basically, and getting it out the door. I really don't care what you use the screwdriver for. You could use it for cancer diagnostics. You could use it as an engineering tool. You could use it to better understand T7.3 whenever that comes along. It's not up to me to decide. It's for me to try to ship that tool. And consulting has just gotten in the way. So now we're actually raising money. Not the best time to be doing that. To just go faster, to jumpstart and get through the manufacturing phase.
When you were looking at your biological product itself, did you have to look into
So the question was, did I have to look into IP? And the answer is yes, absolutely. And I happen to know the IP in that area very well. And in particular, I was going around one of my previous patents that somebody else owned and wouldn't give me access to. And so another reason for the startup is I'm tired of inventing things that somebody else controls and messes up. So I might well mess up this one. That's entirely possible. But at least it's me messing up and not someone else who demonstrably doesn't know what they're doing, right? I wanted the chance to make that mistake myself.
When you talk about you chose to outsource things because was your primary idea that you wanted to address the safety issue, or were you looking also at big things like saving your time or saving costs and stuff like that? What was your primary reason for outsourcing everything?
It was both. So I was solving a problem that I'd solved before, but I had to go about it a very different way to get around the previous patent. Had a basic idea in mind, went out, found some things in the world that did what I wanted, so these things are bits of proteins, designed a new protein, sent off the sequence to have the gene synthesized, they FedExed the plasmid somewhere else to make the protein. So I definitely didn't want to have to do all that myself. First of all, I know some bench biology, some bench molecular biology, but I'm in awe of some of the people I've collaborated with, right? And I knew that I didn't want to try to pull off a lot of that stuff myself. I also knew that it was going to be too expensive. Even growing E. coli is not hard. We often do it accidentally. Growing it in ways that I could make use of to work my way to a product would have cost actually a fair amount of money, and I didn't want to get involved in that either. And I didn't want the orange biohazard suits at the door. There must be something else out there you guys want to talk about. I mean, I'll keep answering questions, but go ahead.
Well, so as someone who's been back and forth between academia and the commercial side of things, one thing that I'm frequently frustrated with is that the papers you see coming out of academia are proof of principle. I did it first. I get the pretty publication and the prestige that comes along with it. But a lot of times those systems, work under. There's so much more effort that can go into making systems robust, and there's so little incentive in the academic world to take it further versus being the first person to have demonstrated it and get that high impact publication. So do you think that there are ways to incentivize more of that development in academia, or is the current mix appropriate and fine to continue forward with?
Everybody hear that?
Yeah.
Okay, so there's a lot in that question. The first thing to say is I don't think you can do anything to fix academia in the way that you use the word fix. The incentive, I would make a little more, a slightly stronger statement about the reward structure in academia. It's not just that you show that it works, it's just that you show that it works once for one figure in that one paper, even if you don't necessarily understand the way that you got that figure, which is often what the development part of making a product is all about. So remember I said the rough rule of thumb, whether this is true for airplanes or computers or anything that I've been able to find, it costs about 10 times as much to do the D part of R&D as the R part. So when I make my protein, right, synthesizing the gene is trivial now, right? It's at most a few $1,000s. Having expression run taken care of is probably a few $1,000s as well, but similarly, well, not similarly, but the quality you're going to get for that few $1,000s may not be there, right? So I get a tube back of my protein. I know that the thing I designed is in there because it produces data that I can't explain any other way. There's lots of other stuff in the tube as well, right? So there's a huge stretch there. Should academia be responsible for bridging all that stuff? No, because academic budgets would go up by a factor of 10 overnight. That's why we have other ways of going about this stuff. I don't have an easy fix for all of that. All I can do is tell you that I tried to minimize those extra costs myself. I knew that if I'd stayed in academia, I could have made this work. It probably would have been easier to fund it on the back end, too, for that matter. But I don't think there's any easy way to change things other than to keep driving the costs down on the commercialization side so that it's easier to make mistakes and easier to get stuff out of the lab and into people's hands.
You're doing an end runner on your own patent, so are you filing a patent?
Oh, it's filed.
How are you, these things get prosecuted, there's constant
I'm sorry?
dialogue between the patent office and those that are doing it, that's a lot of money.
It is a lot of money. So if the question is, how do you get a patent filed without paying a lot up front? The answer is you file a provisional, and then you jump ahead to the international filing, and you pack way too much into the patent, more than will ever be actually allowed by any given office, in the hopes that you can pay for unpacking the patent into as many applications as need be later. It's a gamble, but I didn't see any other way to go forward.
What happens when everybody does that?
When everybody does,
Packs the pads with
everybody does it now.
and one.
That's totally the way it works now.
Right, so, but
And it's broken.
as synthetic biology grows, what happens?
Oh, it gets worse. I'm not going to tell you that I'm not contributing to the problem right now. I'm just trying to make a company work. I'm trying to provide a tool, and there's.
To defend what you did, I'm asking you more to comment on what you think will happen. Because this is a problem not only in synthetic biology, but in a lot of other areas.
That's true. I think it just gets worse until we get real patent reform, or until we get some kind of open source structure. Drew's here now. He can, if he wants to say something about the license.
Maybe I'll rephrase the question: how fast do you have to get your open source structure up and running before it's too late?
That's a great question, and I don't know what the answer is. It may be. Is it too late now? I don't think so. How long do we have before we get a jam up? No, I'm happy to address that question. I just don't. I'm also happy to say I don't know what the answer is. Sooner rather than later.
There's a conversation tomorrow morning around the legal framework, and I would encourage folks so interested to participate there and hear what's been going on.
We definitely have. I mean, the patent situation right now is already a mess. Is there a thicket already in place in synthetic biology? Maybe, but if you look at the state of the technology versus where it's likely to go, and I should back up a little bit. So when I compare biology to other technologies, aviation, computers, whatnot, it just feels really early. So I suspect that what's going to happen is we're going to look back at this and it won't seem as bad as it does right now. That's not to say we're not going to have some hiccups between here and there, but I think it's really early. I think that technology is going to change dramatically over the next 10, 20 years. And I'm not going to try to predict where it's going to go, but it's certainly true that we need some kind of IP work. Something needs to happen.
Do you know of anybody else doing things like you have or arguing?
I don't know. So I wrote an article in Wired in 2005 or so where I said, hey, look at the costs. Everything's crashing. You should be able to do this in your garage. And when it was published, I realized, okay, I don't know anyone doing that, so I should do the experiment, which is part of the motivation for setting up my own shop.
Keeping a blog and sort of documenting how to.
You're turning into a reporter? Or you're feeding me questions? You're feeding me answers, rather?
I'm anticipating.
Right.
I'm hoping the answer is yes.
Yeah, there's a blog, but there's not a lot about the company yet, but there'll be some more. Someone must have something else. It can't just be about my experience. Come on. It's a round table discussion, even though I'm sitting in the front of a lecture hall by myself. Drew.
What was the subject of the session?
This is a real question.
This has rock.
Sorry. Oh, go. Yeah,
I was
please.
saying, I mean, the session.
Thank you.
Is the session titled Commercialization of Genetic Parts?
Right.
We were talking just a little bit earlier about the open source framework,
Yeah.
stuff like that. But is there a market for genetic parts at all, or is it going to be purely a open source thing in which other things are built, or is it going to be like how the Virginia Bioinformatics Institute pictured it, where people have built their own little databases that have their own proprietary stuff and mix in bits from that licensed stuff? There wouldn't really be much of an open market for it.
So I think it depends on, you know what, I'm going to let somebody answer that first. That's great. Round table. Somebody. Did anybody else? Here.
Okay.
Yeah, there you go.
Save me from the mic.
Well, the question was basically, is there a market for, a commercial market for genetic parts in terms of, because we have several possible models in front of us. One is, full open source, it's all free, so essentially there's no commercial market and everything is built on top of that. The other sort of maybe opposed thing is one similar to what the Virginia bioinformatics people sort of postulated, whereby you may get, you get proprietary databases built up by users, and they'd have all their own patented parts in it, and maybe borrow stuff from the BioBricks stuff. There wouldn't be much free trade. And then in the middle, traded parts may be protected by patents in order to be able to trade them or apply a value to them. And which of those people think is going to turn up, and why?
No, seriously. I think it'll just be download the part. Sometimes it'll be free. Sometimes it'll be a small charge. I don't think you're going to see really a market for high-value parts right now, at least in the current ecosystem.
So those parts are going to be protected by a patent, or they're going to be in the public domain, or why even bother with iTunes?
It's a distribution network. I don't know how they're going to protect it. If I was making parts now, I'd just put it out there. But I think there's some value in the actual code, and the fact that it's robust. We see it in the registry already.
Actually, it's the low value. How do you get people to trade them with you? Because I think your point earlier was you couldn't actually get the patent. They wouldn't negotiate with you. I mean, a lot of it's lockup as well. So is there a market for low value parts?
I think the most interesting thing about that is that you couldn't get the part, but biology allows you to create another part that can maybe get the same job done. And so I think that for the vast majority of parts, it's not that there's only one promoter or one protein that could do what you want it to do. So if it's an exceedingly high value, then you can just use a different one. And so that's why I don't think there will probably be, by and large, very, very high value parts.
At the same time, I'd rather pay $10 and reinvent the wheel. So,
Sure. And you can imagine paying for parts, or you can imagine paying for information on those parts. The parts could be free, but if somebody's done the legwork in explaining to you how it will operate under different conditions.
Copyright the specs. Wow, that's an interesting idea. That was actually, I think Ed was in the court here about that.
All right. So let's hypothetically say that you have that people are studying, putting out a whole lot of free parts out there, and you invent a wonderful part that makes rectangular widgets, and lo and behold, you discover that Joe Schmo company is now patenting not your part per se, but the use of your part in some particularly profitable application. And that process starts repeating itself, which appears to be sort of the direction, as I understand it at least, where this could go. After a while, how much incentive are people going to have to put parts out there for free when they see that they're being taken up, when they put it out for free into the BioBricks database or whatever, and the most lucrative applications thereof are turning into somebody else's intellectual property?
Yeah, I really wanted to answer that question, actually. I was just going to second that point. Because
you just really want an answer?
the answer. So we're basements, right? So if
For those who don't know, Jason is Ginkgo Bioworks, or part of Ginkgo Bioworks.
We're trying to do a startup built on top of open parts. We'd love them to be open. That'd be great. It's cheaper for us. So in answer to maybe the original thing that brought this up, I think there's definitely a market for
charging for parts because that's how it works right now. You know, there's lots of companies that sell plasmids and everything else. People are definitely paying right now for parts. That's not that would be the status quo in my opinion. So the real question is there a way to get a functional ecosystem around open parts, right? And that's the point you just brought up over there was great. You know, if we wanted to build a product on top of open components, how do we do that without screwing over the community or otherwise, like, you know, basically, you know, how does it work in open source? Open source software whereby people seem to be comfortable that Google is making billions on open source software and people are still making open source software, you know, right? So what is it, how do we feed back to the community in a way that's appropriate so people don't feel like that, don't stop giving components back? It's a positive feedback loop. I don't know the answer, but it'd be nice to know from people who make parts what would make them feel good if someone went and used their part as a part of the larger system to make money. Yeah. So I asked the round table. Like it's just improvements. Like we'd be happy to give back improvements to the open part package and stuff. You know.
A couple of comments. There are models like Red Hat, for example, that provides products and services built on top of open software that derives tremendous value, right? So you don't necessarily have to concern yourselves with owning everything that comes out. Maybe it's the labor and things derived therefrom that gets you your value. I think just to make some summary comments, I don't imagine an iTunes model being realistic in synthetic biology anytime soon. The cost of replicating from information the existing collection is of order, you know, $1 million today, and even if the cost of synthesis were to drop by a factor of 100 over the next decade, right, and get us down to a penny a base, we're still looking at 10 kilobucks. Now, people obviously don't download the whole iTunes product catalog at once, and so maybe there's a mixture there. I think that the current practice is a combination of things protected by patents and public domain. I think public domain is very weakly supported by tools, and so it's very hard to declare something to be in the public domain or to provide any sort of comfort or assertion around downstream liabilities or freedom to operate. So I suspect one of the great opportunities vis-a-vis commercialization of parts, especially with respect to establishing an open parts platform, would be to provide better tools around looking at what's happening within the space of patents, providing best available technology to clarify some of that. I know Richard Jefferson has done some work around that out of Cambia. There's one more thing that was worth saying, and it's left my mind right now. So again, I think for this session, it'd be interesting to focus on the economic aspects of stuff and to charge the lawyers who are showing up tomorrow with implementing the scheme.
So if you, just one second, I want to make one observation, actually, about, we keep going back to this metaphor of open source software. There are legal reasons why DNA is not the same thing as software, right? You can patent DNA code, you can't copyright it. You can patent software, you can also copyright software, and that's what makes the GPL work, even if Drew is going to disagree with me on that. But I think what...
I'll disagree with you on that.
That's fine. So the only other comment that I would want to make before passing off to the law professor back there is I think there's something interesting about software. Why don't people give their software away? They could put it in the public domain, but often they don't. Usually it's released under the GPL or some other open source license. So there's some reason why people choose that kind of control over their own work as opposed to just throwing it out there for anyone to do anything with. And I'll just leave that as a question. I do explore that a lot in my book that's coming out next October. But it's something to think about as you try to understand how to commercialize your own parts or possibly put them in the public domain. So do you want to...
Let me hand off to Steve by remembering my thing. Just another fact. You know, the 1,000 parts that came in around iGEM last year, if you imagined wanting to patent them, the costs around that at of order 20 kilobucks a pop would be prohibitive. And if you had that $20 million, you probably would spend it not on lawyers, but on making better parts.
So there's a scale of how things are moving, which is very interesting to consider and makes certain aspects of things perhaps impractical. So far as the trolls who are taking something and deriving great value from it, a counter to that would be to build a community of people, right, who are out innovating them, keeping that in the open to an extent, right? So you don't have to necessarily rely only on hard legal power. There's a tremendous amount of soft power associated with an open community.
I'll meet you halfway. No possible remark can live up to the floor show before, but I just wanted to say I was really struck by the Amorous talk yesterday. And you start with a collection of parts, and then you go up 3 orders of magnitude in how well they work together. So experience is really, really important. And I think the point about experience in parts is exactly right. There's a distinction there. And the thing that angers people in the new economy world is that you get a patent on what's basically a trivial invention, but there's a big standard tied to it. And so you get to own not the part in our analogy, but everything that people have done to improve it. So you could imagine that all those Amorous steps might have been done by 5 different corporations, none of whom owned the part or the experience. The trick is to get them to share the experience, but that's a stable outcome. You can imagine a world where once people start doing that, everybody plays that game. In the same way that you can also capture all the experience within one corporation. And the final cost to the consumer is very different. So these are, in a sense, choices that can be engineered if you're smart enough to tip the world to the model you like, if you get in early enough instead of the model you're afraid of.
So how do you do that?
Well, the cynical way to do it, I think, is that there's a lot of public money here. And when Bill Gates cornered the software market, he had the decency to use private money. You've got public money in the game now, and so I would like to believe that somebody somewhere would say, you know, we're putting a lot of skin in this game, and we'd like private parts. Public parts. I don't think DOE is like that, but I think it would be a good thing for them to do.
Yes. Whoops. Not going any further.
I'm going to be speaking in the legal rights panel tomorrow, and I was just wanting to address the sort of sharp distinction between let's talk about the economics here and let's talk about the legal stuff tomorrow, because there are parameters to what can be done with the legal property rights that may or may not subsist in these parts. But the legal arrangements have got to follow what people actually want. So this question earlier about what would make people feel good when they develop a part and then someone makes money from it, that question varies from one area to another. You can't say let's do what the software guys did, because people's feelings about their investment and what gets done with it could be quite different in this area. So that question didn't really get answered, and I think that's a question that needs to be answered before the lawyers can step in and solve the problem. Not that we can anyway, but...
So I have a very simple answer to that question, and it's very naive. It's not involved or by law or technology. And it seems like the reason that there's a lot of tolerance for Google making so much money is that Google gives a lot of free services back to the community. And so I can imagine a parallel here where there could be a lot of comfort with a company making a lot of money by putting parts together if that company is also giving back free services to the community. Because the motivation for people to do stuff in public databases is for public flourishing, for public good. So if the company is contributing to that, then it's like it's giving back something.
So don't be evil.
I just wanted to caution everybody, I'm a software engineer, against overusing the term open source, because I run into GPL issues all the time. So there's a big distinction between the GPL, which I would call a bad open source, because it's viral and it forces you to give away everything that you work on. And so it's kind of anti-capitalistic. I prefer making money. I like capitalism. I think it works. Versus a NetBSD or FreeBSD or any of the BSD licenses, which allow you to give your work in open source, and it also allows someone else to commercialize it, and other people get the benefit of that.
What license does Red Hat use? But that's inconsistent with what you just said. No, they make money from the services they give to. As an organization using the GPL, they make money. They're publicly traded. They don't really.
So is IBM mostly relying on BSD now or GPL? The answer was BSD.
So. Clarification, you can sell the software, but you have to provide it under the same license as which you obtain the core technology, which means you have to deliver anything proprietary that's integrated with the software as free open source. And so
and
the
you
idea,
can improve it, you have to give away your.
That's right.
That's
the thing. Yeah, you can sell packaged open source software, but you do have to donate back the improvements.
Right. Put a bunch over here, and then I'll come back in. Andrew?
I was just going to point out that Google's economic model is interesting because yes, it's built on a foundation of open source, but they apply a proprietary layer over it, which allows them to make money. But the thing that I've always found fascinating about Google is that everyone gets what they are willing to pay for. No one's overpaying Google. There's an auction market around AdWords. Most of the services, as you point out, are free. People actually trade privacy or giving up their data to Google in exchange for a lot of these services. So I think there's actually a possibility to create a Google of biotech, and I think this is one of the reasons why I support open biotech. I don't think an individual part is that valuable. Now, today it is. If you look at the biotech industry, individual parts make most of the money.
I think we should distinguish going forward between the parts that work in circuits, like most of the stuff that Ginkgo might be selling, and the thing that I treat as a part is actually, by itself, the gene for the thing I designed doesn't have that much value. You have the protein in hand. So a part for me is very different. The thing I want to ship is very different than the thing Ginkgo is going to ship, as far as I understand what Ginkgo's doing.
Right.
Yeah.
And I think as we start moving towards more of a BioGrid-based system, I think as you pointed out in the past, the cost of patenting is a lot more than the cost of
the thing, yeah, my patent costs already exceed the development costs of the item itself. Yeah. There was another question over here somewhere. Ed?
Maybe a dumb question that everybody's already answered in their own heads, but I just haven't myself. We seem to be talking about a form of, and I think you made this point earlier, but I didn't hear sort of a cogent explanation. We seem to be talking about a form of intellectual property that's not applicable to the form of matter that we're dealing with. So does somebody have a clear plan for how these types of copyright type IPRs is going to be translated into the biological arena? Or is this just, so what's the basis of this conversation in legal terms? Or
Unfortunately, Drew just left. Steve Maurer is not here. Janet? Oh, we do have someone here who wants to say something.
I would say come to the Legal Schemes and Rights panel tomorrow morning at 8:30 a.m.
So I would just... Go ahead. Janet's book. Yeah, that's right. Bio Bazaar, everyone, on your bookshelves today. Yeah, go ahead. I do, so I'll give 2 sentences from my physicist perspective, not a lawyer. Don't take it home and use it. So you can patent a gene, and what that means is you can use it in the context outside in an artificial context. You can't control its use in the organism, obviously. You cannot copyright a gene, which means that the contract law that's built on top of that makes the GPL work can't work for genes. You can write a contract for each gene with each customer in each interaction. But that's what we would be stuck doing right now if somehow there was no patent on the part. Or you can put it in the public domain, and the BioBricks Foundation has some strategy to build a license on top of that, and I shouldn't say anything about that because I don't know anything about it. Did I get that mostly right?
It is actually possible to write a patent license that is very similar in its effect to the copyright licenses in open source. But the problem with using patents is that the rights, the legal rights, are not actually protecting exactly the same thing. So there is no two-sentence answer, and it comes back to what I was trying to say about you need to know what you actually want to achieve before you can, say what legal rights are going to apply to that. So how leaky the sieve is going to be when you try and collect everything back into a common pool, that is dictated by the shape of the property rights that you have in the parts. And you need to know how leaky you can tolerate, and you need to know, what's going to preserve the incentives for the people to keep doing innovation and sharing with each other. So the economics is really tied to the legal answer.
Yeah, you said you weren't so sure about the definition of a part because for you it's the protein made in hand in a good concentration that you can ship it out, and for Ginkgo it's a part essentially.
It's gene.
Yeah, well, for me what I see there is for you to get that protein at the high concentration, you'll have had to have put together some genes into some circuit into something that then expresses it. So when I keep hearing about, well, do we have some ownership on the biobricks and some copyright, I think the individual parts, I can't see a way that that can be something that people are patenting and making money out of. But once they're put together into a device, that's the sort of thing that people are going to claim ownership of. And maybe a way going forward is that the parts are free to commerce as well, with the kind of community where if they're using them in circuits, they'll probably make more parts themselves or improve on parts that they use in their service, and they put parts back into the community for everyone else to use.
The thing I'm finding tricky about this whole conversation is it assumes...
There's only one thing.
Only one thing. Is that it assumes that everybody, all the actors are being kind of well-behaved and friendly and so forth. I mean, the reality of what's happening in biotech is if you were to develop something that was useful, probably another company with far more resources than you that wants to use that will find a way of tying you up either by having a similar patent which they can then litigate and hold you at bay for the next 10, 15 years while they exploit it. Or they might buy you out if you're lucky. I mean, the reality is that you're dealing with beyond getting a patent, you're dealing with defending a patent, and even if you do it through an open source route.
So I agree with you completely, and the way I would say it is I expect humans to behave in this area exactly as they have for all of recorded history. And unfortunately I can't speak very well for Drew, but having just been in a fairly animated discussion with him a few nights ago about this, I can at least try to convey that he's hoping to build something. He's hoping to build some kind of barrier, some kind of firewall. Yeah, I don't know. So this doesn't carry the right connotation, but just this creation of a community that works in a way that the thing you just described doesn't. The cynic in me looks back at all of what we've seen before and says, well, good luck. I'm going to do my best to help, but I don't. Yeah, you're right. It could be a problem. A few minutes left. Any other thoughts, questions? Nothing else? Well, then we have a few minutes to move on to the next session. Thanks for coming, everyone.